we can solve any quadratic by completing the square, just by making that trinomial a perfect square trinomial. Here's what you have to do. You have to notice a pattern here. The middle term of a perfect square trinomial is going to be, or your coefficient is going to be half your middle term squared. Let's take a look at what we just did up here. When I look at that term, notice 49. If I take 14, I take half of that, that's 7. You square that, you get 49. So what we're going to do is we're going to force it into a perfect square by making that last term half of our middle term squared. And then we're going to solve it like we do the square root property. Let's take a look at example 4 here. Is negative 12? No, it's not, because it's a negative. So here's what we're going to do. We're going to move that negative 12 to the other side first. So we're going to say x squared plus 4x equals 12. Notice I left a space, and I'll explain why I left a space in a second. Now, here's what I'm going to do. I'm going to take my middle term, 4. I'm going to go to the side here. I'm going to say half of 4, and I square that. Well, half of 4 is 2. I square that, I get 4. So I'm going to add 4 to the left side. Well, I can't just magically just add 4. Let's add 4 to the opposite side also. So now, this term is a perfect square. So we're going to say, oh, x plus 2 squared equals 12 plus 4 is 16. So at this point, we're going to take the square root of both sides. So we're going to get x plus 2 equals plus or minus 4. Now to get x by itself, we subtract 2 from both sides. So we get x equals, notice my 2's cancel, negative 2 plus or minus 4. So we get 2 answers here. Negative 2 plus 4 is 2. Negative 2 minus 4 is negative 6. So x equals 2 or x equals negative 6. There's your answer for that one. Let's try another one. Let's take a look at example 5. What do you do when the number in front of x squared, when you have a number in front of x squared? It gets a little bit more complicated. That's what happens. First thing, move the 1 to the other side. So I want to move that negative 1 to the other side, so you get 3x squared minus 2x equals 1. You can't have a coefficient for our perfect square trinomial, otherwise it's not going to work. So what happens is I'm going to divide everything by 3. So we're going to get x squared minus 2/3 x equals 1/3. Divide everything by 3. Now your coefficient is x squared. Now your rule works. So this is where it's kind of nice to have the work on the side. I'm going to take half of negative 2/3, although it doesn't matter with the negative because I want to square it. Well, what's half of negative 2/3? Well, half of negative 2/3 is 1/3. I square that, I get 1/9. So I'm going to add 1/9 to both sides. Well, let's factor that. The square root of 1/9 is 1/3. The middle term is negative, so we're going to say x minus 1/3, the quantity squared. On the right-hand side, we have to add those up. Common denominator is 9. So the 1/9 doesn't change, but 1/3, you have to multiply that by 3, numerator denominator, to get a 9. So you get 3 plus 1 over 9. So x minus 1/3 squared equals 4/9. Now we take the square root of both sides. So we get x minus 1/3 equals plus or minus, well, what's the square root of 4? Well, that's 2. The square root of 9 is 3. Oh, you get plus or minus 2/3. Well, at this point, we're going to add 1/3 to both sides. So then we're going to get x equals 1/3 plus or minus 2/3. Well, 1 plus 2 is 3, so you get 3/3, which is 1. Or 1 minus 2 is negative 1/3. So x equals negative 1/3 or x equals 1. These can become buggers because of the fractions. Okay, let's do another one and show you what happens on this one. Okay, first thing we're going to do, we're going to move the 11 to the other side so it doesn't seem so bad. So x squared plus 4x equals negative 11. On the side, I'm going to take half of 4. And we're going to square that. Half of 4 is 2. So 2 squared is 4. So I'm going to add 4 to both sides. So we get x plus 2, the quantity squared, equals negative 7. Well, then we take the square root of both sides. We get x plus 2. Uh-oh, we're taking the square root of a negative, aren't we? So that will be plus or minus I times the square root of 7. Finally, to get x by itself, minus 2 from both sides. You can't really simplify this one, can you? So you get x equals negative 2 plus or minus I times the square root of 7. Nothing simplifies there. You're done. Finally, we're going to use completing the square to write a quadratic function in vertex form. Remember, vertex form is y equals a times x minus h, the quantity squared, plus k. So first thing I'm going to do, I'm going to rewrite this problem, and I'm going to separate it out a little bit. I'm going to put the x's together. So y equals negative 3x squared minus 10x. I'm going to leave a spot, and I'm going to go plus 12. Now, rather than dividing, which we could, but we don't have two sides, we're only dealing with one function, I'm just going to factor that negative 3 out. So I'm going to say y equals negative 3 parentheses. That'll be x squared plus, because we're factoring out a negative, plus 10/3 x. And I'm going to go plus 12 here. Well, now, let's take half that middle term and square it. So half of 10/3. And I'm going to square that. Well, half of 10/3 is 5/3. So I'm going to square that, and I'm going to get 25 over 9. So I'm going to add 25 over 9. Well, really, I'm adding negative 75 over 9 because I have to distribute that negative 3. So if I add negative 75 over 9, or subtract 75 over 9, I have to add 75 over 9 over here. Because we take negative 3 times a positive 25 gives us negative 75 over 9. So if I put a negative in there, I have to put a positive because I have to add 0. Because I can't just change my function. Now let's factor this. So you get negative 3 times x plus 5 over 3 squared. Now let's get a common denominator here in our last term. So our last term, we're going to say we need a common denominator of 9. So I have to take 12 times 9. Let's use a calculator here, because sometimes I mess this up. I think it's 108, but I don't want to make for sure. It is 108. So you get 108 plus 75 all over 9. Well, I'm going to rewrite that as negative 3 times x plus 5/3. And then let's go 108 plus 75. We get 183 over 9. See, does that reduce? 8 plus 3 is 11, plus 1 is 12. 3 goes into both of them. So I can reduce this by dividing numerator and denominator by 3. Whoops, got an extra line there. So we get negative 3. Let me change that back to purple. Times x plus 5/3 plus, that will be 61 over 3. I should have put y equals on each of these. Now what's the vertex? Well, since it's in vertex form, remember inside it's always backwards, so it's negative 5/3, comma, 61 over 3. Forgot my squared term there. And there we have it. Vertex, and then vertex form. And I made them nice and ugly, for example, so hopefully when you come across the ugly ones in your assignment, you'll be able to knock those out of the park.